Welcome back to part 2 of the Delphi filter ordeal. The supplier has sent me some new parts in the post, but because of where I live, deliveries take ages. I'm running out of time and I don't really want to continue waiting for some parts which may or may not solve the problem. So I've done some reworking myself. In doing that, I found some more horrors with the Delphi filter, one of which is especially concerning. Let's take a look. Thanks to Rick for his comment about the sound quality. I use a waterproof cover on my phone to keep iron filings and dust out, and I forgot to have the little charger flap open. So hopefully the sound quality is a bit better on here. Speaking of quality, you remember this bottom tray was running kind of skew-if against the spindle. The spindle wasn't perpendicular, so that when it pulled up on the filter head, it was pulling up skew-if, allowing a leakage. Simply by facing off this part in the lathe, this face, and making a new stem bolt with a shoulder that locates against the nicely faced off thing, this is now good. That tightens up against that shoulder and the stem is now perpendicular and there's no more warped record, so that's going to pull up tight. So that's one problem solved. The stem and base for the actual filter canister itself, this was running true previously, but in looking at it I noticed that the thread in the top, which is 1/4 UNF, that's just over 6mm diameter, wasn't especially a nice looking thread, and if that tiny little bolt fails, poof, off it drops and the contents of my 1200 litre tank end up in a river, which doesn't seem very optimal. So I've made a new stem for here, again with a shoulder on that locates on there, and it all runs nice and true. Brilliant. Another issue was that the holes in the filter head were not concentric with the bores into which the stems locate, causing a skew-if assembly. That too has now been fixed. Being a die-cast item, these stem bores in the bottom are tapered to allow the die to withdraw. So I've machined up a tapered spigoty mandrelly thing onto which the head locates nicely, and using a milling cutter I've gone down, having centred that on the spindle, which now means that the hole in the top, whilst enlarged, is concentric with the hole on the bottom. There then follows a countersink bit to ensure the countersink is concentric, followed by a flat bottom slot drill to face off the top to make sure that's all good, and to allow the new bolt to go down that little bit further because I've deepened the countersink. Intriguingly, the angle of taper on the other hole doesn't match the angle of taper on the first hole, so this mandrel here is double-ended with two different tapers on because they don't even match, and I've used the other end to locate on there, which, as you can see, is a wobbly fit on that one. So the head would now seem to be all good, wouldn't it? However, because I've gone down such a rabbit warren with this filter, I'm starting to look at the oil drillings in the top. I've reconfigured this filter. When it arrived from the supplier, the sediment bowl was on the right and the 296 canister filter was on the left. I've swapped those positions round, in fact, to put them in line with the illustration on the supplier's website. But being a cautious person, I start to think, hang on, am I doing something here I don't understand? Have I cocked something up? So I start looking at the drillings underneath to make sure I've not done anything silly. And the drillings don't seem to make sense. Maybe I'm just trying to be too clever here. I've compared the head to a Bepco copy of the same head and found that the drillings are identical. So clearly I'm overthinking this, and I put it all back together, and this time when I blow in one end and blank off the other, there's no leakage and it's airtight, which is a win from the previous situation. But I still can't get my head round that cross drilling. Fluid will always take the path of least resistance, and by studying the drillings in this filter head, it appears that the path of least resistance will allow a direct path past the blocked filter straight to the outlet, which surely can't be right. I just can't get my head around this. So, having slept on it, and because my delivery still hasn't arrived, I've blanked off the bottom of the filter to simulate a total blockage. In the event of a total blockage, it should follow, of course, that when you blow in one end, nothing comes out the other end. Let's see what happens. I'm not going to film myself trying to blow through this, and you probably won't hear the air leakage anyway. Neither do I want a compressed air line on there. But with the filter taped off and everything done up tightly, it's still allowing air through the inlet and out of the outlet, which means that if you put fuel in there, it would allow unfiltered fuel straight into the business end, which is the whole point of, or rather, which is the whole point of not having a filter. Which is the whole point of a filter, to not allow dirty fuel through. I've recontacted the supplier to ask if I've overlooked anything obvious. Is there supposed to be a retrofit blank that you are supposed to put in there once you've configured the filter head? They don't have any immediate answers, and I'm waiting for them to come back to me. But in the meantime, to further prove this hunch, I'm going to make my own blank, shove it where I think it needs to go, and then we'll repeat that test with the blocked and then unblocked filter. To show you where my concerns are, this is my inlet, plumbed with the in arrow. If anyone thinks I've done this wrong, please comment, because I've spent a lot of time thinking about this. This is the inlet. It delivers fuel into the top of the sediment bowl through there, which is the same situation if you use the in arrow on there. It delivers fuel through a drilling straight into the top. So it can't be according to which configuration we've used. Anyway, delivers fuel into there. Fuel drops into the sediment bowl. But from there, it's got two ways into the next part. It can either go up past the stem into this drilling, which runs through here, or it can go through that hole there, which comes out there. That takes the fuel to two different sides of the filter canister. If the fuel follows the path through this drilling, it will take it onto this part of the filter, but if the fuel follows the path past the stem along there and on there, it takes it onto the other side of the filter. Just doesn't seem right. Important to note that the original stems were not a tight fit in there and had no O-rings on them, so there was no means of sealing or blanking this off. The easiest path through, which is the path you would expect, is through the larger drilling. So it's through there, into the top of the filter, and as anyone who's ever taken any of these apart, this is where all the crap collects, in the top. Fuel would then, by reasoning, pass through the filter, through these obstructed apertures on the bottom, where it's then free to flow up through there, past the stem, and happily towards the outlet. Filtered fuel. That's all great, but there's this shortcut from that stem hole to that stem hole, which allows unfiltered fuel through. My rationing is that there needs to be a retrofit blanking plug installed either there or there. I can't work out which is best, but there's a bleed screw on top which could kind of affect things. But as it is, this just surely can't make sense. So I'm going to scamper off now onto the lathe, turn up something to obstruct one of these holes. I think I'm going to put the blank on the sediment side, because then that allows this bleed here to bleed the top of the filter off. I've turned up a little aluminium bung, aluminium so it's soft, and I've put a taper on there about similar to that of a taper pin so it can be smacked in, and if I've got this entirely wrong I can hit it back out from the other side. So I've put it all back together, thinking I've fixed the problem, taken my little blow down the end, and there's still air leakage coming past. So this is with the cross drilling blocked off and the filter canister taped blank to simulate a blockage, and we still have flow through the outlet, which is allowing unfiltered fuel through, which if you have anything with a diesel injection pump on, and it's an expensive failure. So what on earth's going on now? At this point I really am starting to question my sanity. So I start to take it apart, and whilst it's coming adrift I spot this on the bench, which is the cone of the water trap, which I haven't put in. Obviously that's not going to affect air tightness in any way, but I remember that when I reconfigured the filter and took it from that side to go on that side, this, which is a plastic item, and a very poorly made plastic item, the original CAV cones are cast aluminium, this is plastic, and I recall that when I swapped it over there was a big shard of a ripped off O-ring on the top, and there was a huge burr on the top which I've subsequently removed with my Noga deburring tool. I examine the O-ring and you can see that it's knacked. So into the stock of O-rings, fit a new one. I mean, it should be possible that things like this can be fitted on and off without destroying the sealing components, but we're in Delphi land now. The days of CAV are long gone. Look at the flash on the bottom of there, it's flipping awful. I'm going to give that a bit more dressing up before I try and refit that. I reassemble the filter, take a blow in, and to my delight there's now nothing coming out of the outlet with the canister blocked. Time to remove my test blanks. And put it back together. This time there's a free flow of air. I'm at a loss to explain why not only this Delphi copy, which we've established is pretty poor, but also the Bepco head, which doesn't have any of the other issues I've discovered with concentricity on here. The Bepco head is far better quality. Both have this mysterious cross drilling which allows unfiltered fuel direct to the outlet. Anyone who's watching this will know that fuel injection pumps are catastrophically expensive to repair and so easily damaged from dirty fuel. How many of us would have just put a new filter head on like this, not gone down the rabbit warren that I have, and just trusted that the filter was going to do its job, when in fact it's allowing unfiltered fuel direct to some extremely high precision parts that need clean fuel. I guess what we can see here, because I'm quite a political person, is the end game of capitalism. Companies that were once producing entirely decent quality products get bought out by the competitors, who then make a load of people redundant, outsource things to other countries where procedures are not in place. The same precious resources of our planet are being used in making this, so the input is still the same, but because of lack of attention to detail, I don't blame the guy who machined this, I blame his management who failed to ensure processes were in place. The same resources are being committed, but the outcome is something that is entirely useless And if this had been fitted to a diesel system, it would in turn have caused the destruction of the injection pump, which then means that we need to consume even more resources. The old one gets thrown in a hole and we dig a new hole somewhere else to mine more materials to make a new one out of. But it says Delphi on there, and they've got every single splat on their paperwork to say that they're quality and OEM assured and da. Whereas actually this should have come straight out of the box and gone straight to the scrapyard, because it was in no way going to do with the job that it was designed for. I may as well have just put the pipe straight through and removed the filter. It would have saved me leaking fuel into the river. That would have been in fact a benefit. What else can I say? I'm not going to name and shame the supplier, who have been reasonably good in getting back to me and trying to solve the problem, and they've been pretty honest in saying that all the other ones they've got are equally bad quality. But as for Delphi, what a pile of shite. I suggest that if you've got something like this on any of your systems, maybe you give it some basic checks to see if you're in the same boat. Hope you enjoyed this. I had no idea I was going to spend so long repairing a brand new fuel filter. Thanks for tuning in.